Welcome to this section of the tutorial that explains how to draw your indoor map. At this stage, you should have downloaded the latest version of QGIS, which is version 2.18 at the time of recording, and have a digital copy of your building's floor plan available. After installing, you'll also need to make sure that you have access to the Georeferencer plugin. Georeferencer will allow you to convert your indoor floor plan to have it correctly related to a ground system of geographic coordinates. That is, making your floor plan image spatially correct to your building in terms of latitude and longitude. The Georeferencer plugin can be found under Raster, Georeferencer. If you find that it's missing, you should be able to find it under Plugins, Manage and Install Plugins. Georeferencer will allow you to convert your indoor floor plan to have it correctly related to a ground system of geographic coordinates. That is, making your floor plan image spatially correct to your building in terms of latitude and longitude. Something else that you'll want to have in place before we start is setting your project's CRS or coordinate reference system to WGS84 or pseudo-Mercator. This is also referred to as EPSG 3857. You can see your current CRS in the bottom right of the QGIS window. 3857 is the CRS that will be used for producing this indoor map, as it shows the world in a way that avoids the stretching and skewing that is present when the map is taking lat-long geographic coordinates into account. Now it's time to get started on the indoor map generation process. Firstly, find the outline that you downloaded at the end of the last video and drag it into your QGIS project. You'll now see the building outline as a vectorized polygon. The outline that you downloaded at the end of section 2 is generated from a third-party data source, for example the OpenStreetMap, and may not be correctly aligned in terms of parallel and perpendicular walls. The best way to fix this is to make your own outline which fits, as much as possible, within the provided outline. Create a new polygon layer from Layer, Create Layer, New Shapefile Layer. Ensure that the CRS is set to 3857 and add a name and type field to the fields list. Name your new layer appropriately and save. To ensure visibility of the layer, place it at the top of the Layers panel. You can double-click the polygon layer in the Layers panel and change the opacity to ensure that you can see the floor plan underneath it. This will also make it easier to see when polygons are overlapping one another. To trace your interiors with precision, you need to enable the Snapping tool. You can find the snapping options under Settings, Snapping Options. Ensure that the layer selection is set to all visible layers and that the snap to is set to vertex and segment. You'll also want to check the Enable Snapping on Intersection box. Your tolerance settings will vary on personal taste, but personally I like using 15 pixels, so we'll be using that for the remainder of the tutorial. Now, if you toggle layer editing on for your polygon layer and activate Add Feature mode, you should see a small pink cross appear whenever you move your cursor close to a polygon edge or vertex. This is the point that you'll snap to. A useful tool for creating parallel and perpendicular polygons is to first create a scratch layer with which you can generate a series of guiding lines. Think of it like drawing a sketch before you draw the main polygons. As before, create a new layer from Layer, Create Layer, New Shapefile Layer. But this time, create a line layer. Next, ensure that Advanced Digitizing is active via View, Toolbars, Advanced Digitizing Toolbar. Select Enable Advanced Digitizing Tools and place your first baseline point. We'll be using this corner as our starting point. We'll place another point at this adjacent corner, then right-click to accept. We now have a baseline from which we can start to generate a straightened outline. From this second corner, start a second line. Now that you're placing a feature, these two buttons will become active on the Advanced Digitizing panel. These buttons will allow you to trace lines that are perpendicular and parallel to the existing geometry. For our example, we want our next segment to be perpendicular to our baseline to get a nice right angle in the corner. Therefore, we select the Perpendicular button. Now, if you move your cursor over the vertex or segment that you would like to draw perpendicular to, as your cursor snaps to the edge, you'll notice the highlight on it, and a blue dotted line will appear, which will show you the path that your next line will follow if you select the edge that is currently highlighted. Click on the highlighted edge and note that, as you move your cursor again, your next point is now locked to that blue dotted line. As this is a guiding line, you can extend it beyond the bounds of the interior without worry. This will give you a bit more freedom for where your next corner will be if things don't line up quite as you expect. The parallel button will perform a similar function, but to create parallel lines instead of perpendicular ones. Continue using these two buttons as you draw around the outline. When the guidelines are finished, you can create a new polygon layer for your updated building outline and simply fill in the gaps by joining the dots. You can ignore the geometry warnings while you're still placing points, but if you still have a warning when you think you're done, you'll want to check it out. Should you make a mistake or want to make an edit, you can do so via the Node tool. This will let you select a polygon and move the individual points around, including snapping. Now that you have a solid starting point, you can start generating the features for your indoor map. The first step in this is to overlay your floor plan over the outline as a guide. Open the Georeferencer and click Add Raster. Add your floor plan image and see that it's now displayed in the Georeferencer window. Georeferencing is the act of associating something with a spatial location. In this case, we'll be associating your 2D floor plan with a spatial location in the real world. The easiest points to georeference tend to be corners, particularly those on the extremes of the building. To do this, select the Add Point tool in the Georeferencer window and select an appropriate point to reference against. In this case, we've chosen this corner. Click the button marked From Map Canvas, which should bring the main QGIS window back into focus. Click the location on the outline that matches the point that you selected in the Georeferencer window. Continue to repeat this process in order to build your perimeter. In an ideal situation, 3 points will be all that you need. Unfortunately, it's rare that this is the case, and it should be noted that every point beyond this has a chance of adding a degree of skew to the map as it's stretched to fit the newly provided positions. As you can see, for our example, we've only referenced 3 points. With all of the appropriate points laid down, you can now set the transformation settings for the Georeferencer tool. Set the target SRS to 3857 to match the project settings, and set a path for where you'll save the georeferenced image. Ensure that the Load in QGIS when done checkbox is checked. Hit OK and hit the Start Georeferencing button in the Georeferencer. After a moment, the floor plan should appear over the outline that you made earlier. Within the Layers panel, identify the layer you've just added, double-click and adjust the transparency so that you're able to see how the outline compares to the floor plan. If your floor plan appears distorted, try the process again using some different points to georeference. And remember that less is more. Congratulations, you now have a georeferenced floor plan image. The next step is to trace the indoor map features like walls, rooms, etc. The first feature that we'll create is the floor plate for the floor. In this case, the general building outline doubles as our floor plate, so we're just going to use the guidelines that we created before to create a new floor plate. In the case that your floor size is not the same as the building outline, you would need to generate a new set of guidelines for this floor. As before, place your outline point by point, and remember that you can correct any mistakes later. Once you're happy, accept by right-clicking. In the confirmation dialog that appears, select Type and change its value to building_outline. Leave both the name and ID fields empty, which appear as null, and click OK. You should now see the polygon of the floor plate over your map. The next step is to add the walls. We generate our walls following a similar process, generating guidelines and filling in the blanks. When adding the walls, leave space for any doors that you want to add later. Door features can be used to cover entrances. If you want to place double doors or sliding doors, you can represent these as a single door polygon. The feature will appear in the app slightly larger than the polygon that's created in QGIS. It's important to keep the doors parallel with the connecting walls, otherwise it will appear incorrect within the indoor map. We can then do the same thing for rooms, bathrooms, stairs, etc. Features like these are the ones that you might want to fill in the name field for. Room names can be room IDs like WPH22, or more human-readable names like meeting room. The same rules apply to the other features, but in certain cases we have specialized icons that can appear instead of the name labels. For instance, bathrooms named bathroom will show a symbol instead. The same for stairs named stairs or escalator, and the same again for elevators named elevator. While it's possible to check your progress incrementally, it does mean repackaging and submitting your polygon layer every time. For the sake of this tutorial, we'll finish the full floor before submission, but you're always free to tweak, edit, and resubmit your floor plans after you've reviewed the outcome in the app. Before we can package up the work, we need to fill one more field, the ID field. Previously, we had mentioned that you could leave this blank. The reason for this is that we can use a script to generate a unique ID for every feature on the floor so that you don't have to do it by hand. Every feature in a building has to have its own unique ID. To do this, we'll be using the QGIS field calculator. Open the attribute table for the layer. From Layers panel, right-click the layer, open Attribute Table, and then select the field calculator from the toolbar, or press Ctrl and I. From this window, select Update Existing Field. Make sure you have ID selected in the drop-down menu, and enter the following function into the Expression tab, where X is the level of your floor. We tend to make our lowest possible level x equals 1 and increment as we go. In this case, we'll be using x equals 2 for level 2. Click OK and notice that all of your attribute table's ID boxes now have a number in them. The next stage is to export your level to GeoJSON. To do this, highlight the layer you created in the Layers panel, right-click, Save As, and choose GeoJSON from the drop-down menu. Under Encoding, select UTF-8 and change the CRS setting to EPSG 4326 WGS84 Mercator. Enter a name and location for your file and click OK. The reason for using 4326 Mercator here, instead of the 3857 pseudo Mercator that we've used so far, is that 4326 points are actually stored in lat longs, which the 3857 points are not. The world system uses lat longs to place the points correctly in the 3D map. If you're doing this for multiple levels of your building, you can just make a new polygon layer and repeat the steps above. Just remember to change the X value that you enter during the ID generation step. The last thing that the WRLD submission service needs is the information that's associated with the building. We store this in an associated Main.Json file. Navigate to the directory to which you exported the indoor map level or levels, and create an empty text document named Main.Json. You can find a link to a template for this document below, or you can type it out manually along with the video. The Main.Json file needs the following: a building ID, which is relatively arbitrary, but we tend to make it something like location_building. In this case, Dundee_Westport_house. A building name, which is the human readable name that will appear on the map. In this case, Westport House. The owner, which is the owner of the building floor plan data, which is probably your company or organization name. In this case, WRLD. The location, a coordinate in longitude and latitude for the building entrance marker, aka the blue door that you would see on the map. You can get this location from maps.world3d.com. Right-click, what is this place? And the levels array, which is an array of floors, each with their own set of data. This is how the building knows which set of data to use for each floor, and which order to put them in the building. If a floor plan was traced and a level exported, but the main.json file does not reference it, the level in question will not be included in the processed indoor map. Each of these levels needs an ID, a name, which is the name that will appear on the elevator when you're in a building with multiple floors. This should be less than 3 characters if possible. For example, 2. A readable name, which is a longer name that will appear on the label at the top of the screen when you're inside the interior. So perhaps level 2 or offices. Z order, which is the order in which to draw the floors in the interior. So 0 would be the bottom floor, 1 would be the next level up, and you would increment by 1 for each level above that. And lastly, the file name, which is whatever you saved your GeoJSON file for that floor as. With all of this combined, we just need to zip up the files and return to the indoor map upload tool for submission.